Hey guys, today we're going to talk about systems of inequalities. Now we've been graphing systems of linear equations, and this is going to be just like that, except for now we're involving an inequality. So I need you to think back to when we first graphed linear inequalities with two variables, and we talked about find the slope, find the y-intercept, and then we talked about our line. And we had to decide if our line was dashed or shaded, and we also talked about dashed or solid, sorry. And we also talked about shading, if we shade above or below. Do y'all remember doing this? I know you do because we just did it just a few weeks ago. So today we're talking about that, but we're talking about a system of linear inequalities. So here, looking at these two lines, I see that one of them is already in slope-intercept form for me, which I love. That's awesome. That one will be really easy to graph. And I see that my other one is not in slope-intercept form. So the first thing I'm going to do with this equation right here is I'm going to set it up so that I can solve for y, because I want to be able to put it on my graph really easily. I'm going to add 3x to each side. That's going to leave me with 2y is greater than or equal to 3x plus 2. Divide everybody by 2. Y is greater than or equal to 3/2 x plus 1. So now that I have this inequality in slope-intercept form, I'm going to put it on my graph. So I know that my b is 1, so I'm going to go to my y-intercept, and then my slope is 3/2 up 3 over 2, down -3 over -2. And I'm going to think about connecting these points, and I need to decide if my line is solid or if it's dashed. And that I have to refer back to my symbol, remember this, and it's greater than or equal to, so my line is going to be solid. So I'm going to have a solid, ooh, that was interesting, a solid line here. And now I have to think about shading, if I want to shade above or below the line. And since I'm also here referring back to my symbol, I'm talking about greater than. I know that I'm going to shade everything above the line. So all of my solutions to this inequality are on the line, they're on this line right here, or they're above that line. Okay, so now I get to go back and I get to look at my second inequality, which is y is less than 4x plus 3. So that's already in slope-intercept form, so I'm just going to go ahead and plot that. 1, 2, start at 3, and my slope is 4, up 4 over 1, down 4 over 1. And now I have to decide if my line is solid or if it's dashed, and that since it's just a plain less than symbol, I know that my line is going to be dashed. So I'm going to have a dashed line here to connect these points. So I know that it is less than, so I'm going to be shading less than. That's everything below the line. So that's everything from my dashed line below. Remember when we talked about inequalities, we also talked about for this second inequality here, since this is less than and not less than or equal to, and I have a dashed line, nothing on the line can be a solution. So when we talk about a system and what the answer or the solutions to a system can be, it's where both pair of solutions are. So I see that I have everything on the red line here that I'm now marking in blue. Everything on the red line is a solution, and above, and everything below, not including this dashed black line, is a solution. So in this small little triangle here, this is where the solutions of this system will lie. On the red line, below the dashed line, and where the two systems overlap. That is the solution of this system of inequalities. Here comes Ms. Sokolowski to talk to you guys about the next problem.
All right, guys, so the next problem that we're going to do here is y is greater than or equal to 4x plus 6 and y is greater than or equal to 4x minus 5. So I'm going to start off by plotting 4x plus 6, my y-intercept of 6, and I'm going to go down 4 and left 1 to create a positive 4 slope here because I'm out of room up at the top of my graph. Then I look to see what kind of line we're going to have. I see that I'm going to have a solid line because it's greater than or equal to. And I see that since it's greater than, that means I'm going to shade above. So I'm going to shade above that line right there. Notice how these were already in slope-intercept form for me, which is awesome. Then I'm going to graph y is greater than or equal to 4x minus 5. So I start down here at negative 5, my y-intercept. I'm going to go up 4, right 1, up 4, right 1, and that also is going to be a solid line because of the greater than or equal to. I'm going to shade. Where are we going to shade here, guys? We're going to shade above that line since it's greater than. Now when I look at this, I want to look for where my two shadings overlapped each other. Where did they overlap? They overlapped starting at this first line, solid line that we graphed, and everything over. So all of this double shaded, I would shade that even darker with my pencil since that part is the double overlap. That is the solution to my system of inequality. So notice all of this part is not included, which really means that that second inequality, nothing from that second inequality got included because the lines were parallel. They had the same slope. So if I wanted to list out here two ordered pairs that are solutions to this system of inequalities, I could list one of the ordered pairs on the line. Since the line is included, since it's solid, that is negative 2, negative 2 appears to be a solution. Probably want to check that and make sure that is a point. I think it is. And then another one of my ordered pairs could be that point right there, which is 1, 2, 3, negative 4, 2, I believe that is. Negative 4, 2, or any of these points were solutions. If I ask you to list any solutions, you could list any of those on the shaded region or the line. If I ask you to list two ordered pairs that are not solutions, we want to look for where there is no shading, which would be any of these points over here. 1, 2, 3, 1, 2, 3. So 3, negative 3 would not be a solution, or any point on this line right here is not a solution because it's not included. 1, 2, so that's 2, 2. So I think you guys should probably understand that by now after these examples. Hope that helps. See you tomorrow.